Hello, welcome. This is part one of the 5.5 notes. This is the last section in Unit 5. So today our content objective is 1, build systems of linear equations or linear inequalities from word problems. And then our learning objective is be able to identify the x and y variables in a word problem, then solve. So these two go hand in hand. If we want to be able to build and solve systems, we need to be able to identify x and y variables appropriately. So let's look at some examples. So first it says, Mary goes to the store to buy jeans and some t-shirts. The jeans cost $50 each, and t-shirts cost $15 each. If Mary spends $210 on 7 items, how many pairs of jeans and how many t-shirts did she buy? So first, let's talk about what each of these things represent in terms of x and y. In this problem, we're going to call x jeans. And we don't mean the cost of jeans, we mean the number of jeans. And therefore y should equal t-shirts. And so if we look at this, it says the jeans cost $50 each, t-shirts $15, Mary spends $210. So that means if she spends $210, that's going to be equal to 50x, the cost of a pair of jeans times how many jeans there are, plus 15y. $15 is the cost of a t-shirt, y is the number of t-shirts. But now we also need to know how many of each she bought. We know that she spent this money on 7 items. So that means that x plus y equals 7 items because it's the number of jeans and t-shirts. We don't know how many jeans or t-shirts she bought specifically, but we do know that she bought 7 items total. So now we need to use these two equations to see if we can actually find out how many jeans and how many t-shirts she bought. So it's pretty simple. We can rearrange this. I'm going to put it in terms of y. So y is going to equal negative x plus 7. Now I can substitute this into this larger equation, and I can substitute it in for y. So now I know I've got 210 equals 50x plus 15 times negative x plus 7. I'm going to distribute that 15 throughout. 210 equals 50x minus 15x plus 105. I'm going to subtract 105 from both sides, and I'm going to do some simplifying. 50 minus 15x is going to be 35x, so that means 105 equals 35x divided by 35. X equals 3. So that means we have 3 pairs of jeans. Well, how many t-shirts do we have? Well, there's different ways we could do this, but really the simplest is I know that 3 is x, so I can put that into this original equation. 3 plus y has to equal 7, so we know that y equals 4 t-shirts. Just some basic math, okay? All right, the next problem says a student is buying pens and markers for school. 1 pack of pens costs $3.25 and 1 pack of markers costs $4.50. If she bought a total of 8 packs and spent $29.75, how many packs of each did she buy? So again, we need to decide what x and y are. In this case, I'm going to make x equal to the number of pens, y equal to the number of markers. And it's really just easy if you just go by, it says pens and markers. Well, pens is the first thing that's explained, both in cost and amount. So just make that x, make the other one markers y. Okay? And we know that the package of pens is $3.25. Multiply that by x. The package of markers is $4.50, y. And that should equal, she spent a total of $29.75. We also know that the number of packs she bought, x plus y, equals 8. And again, I can rearrange. Y equals negative x plus 8. And I can plug this in for y into this equation. So we're going to have 3.25x plus 450 times negative x plus 8 equals $29.75. Now I can just go through and distribute. 325x minus 4.5x plus 36 equals 29.75. All right, now I can subtract 36 from both sides. I can combine like terms, 3.25x minus 4.5x. I'm going to get negative 1.25x is equal to negative 6.25. Divide, and we're going to get that x is equal to 5. Therefore, y must be 3 because y and x need to add up to 8. So we have 5 packages of pens, 3 packages of markers. All right, last problem on this page. Says a company has to buy computers and printers. Each computer X costs $530 and each printer Y costs $365. If the company spends $6,795 and buys a total of 15 machines, how many of each did it buy? This one's pretty easy because it actually tells you what X and Y are. Right? X are the computers. Y is equal to number of printers. And we know that X plus Y should equal 15 total devices. And then our other equation, we know that a computer costs $530, so 530X plus 365Y for a printer, and that should add up to $6,795. We can take this equation, rearrange it, and put it in terms of y if we want. So y should equal negative x plus 15. Now we can substitute that in to this equation, 530x plus 365 times negative x plus 15 equals 6,795. Now I just need to distribute. So I'm going to get 530x, minus 365x plus 5,475. That's 365 times 15 equals 6,795. Now I can subtract 5,475 from both sides of the equation. I can combine the like terms. 530 minus 365 is going to give me 165x is equal to 1,320. Divide both sides by 165. X equals 8. And that's the number of computers. Therefore, y will equal 7 because x plus y needs to equal 15. And that's going to be the number of printers. And those are just a few examples of how we can use linear equations or linear-like equations and systems of linear equations to find unknown x and y values.